Good morning, grade fives. I'm here to work, oops, sorry, shaky camera. I'm here to work through your math for today. I'm working on getting a better way of shooting, but for now it's me and my phone. So I'm trying to figure it out, so please be patient with me. So it's me and my phone right now. We are gonna go through and just go through the math so that if you're done, you can check it and make sure you're on the right track. If you're stuck, you can look at this video and hopefully it will explain it to you. Now, if you watch the video and you're still stuck, that's okay. Send me a message and I will try to help you. Right now I'm at school in front of my computer, and I will be here during regular school hours to answer your questions whenever you have them. So on that note, I'm going to get started with Monday, March 23rd, the math for grade 5. Okay, now remember that when we get our daily math, sometimes you might think, I've never seen this before, but it's always building on things that have been in the math curriculum or things that you've tried or done in different ways. Sometimes the words might not make sense, but it's all similar. So we're going to look at this. We're going to complete the pattern. 14, 17, 20, 23. Now if I look at this, I know between 20 and 23 it's plus 3. Between 17 and 20, it's plus 3. And then 14 to 17 is plus 3. So let's check. 14, 15, 16, 17. So yep, that's plus 3. 17, 18, 19, 20. Yep, plus 3, plus 3. So I know this is a plus 3 pattern. So let's go. We're going to count 3 more. So 23 plus 3 is 26. 26 plus 3 is 29. And 29 plus 3 is 32. So looking at this, 29, so 26, 29, 32. Okay, so that's the first one. I'm going to go to number 2. What is the missing number? So how would I figure this out? 70 take away something is 43. Now remember, addition and subtraction are the same, they're just opposite. So to figure this out, I could very easily, I have to figure out 43 plus what equals 70. That's another way to look at it. So whatever way makes sense to you, you can look at it. If I'm going to find the missing number, I'm just going to start at 43 and I'm going to count up till I get to 70. So I'm going to use an empty number line. So this is 43, and I'm just going to count 43, 53, 63. Now I can't, those are jumps of 10. I can't jump any more by 10s because otherwise I'm going to get to 73. So now I'm going to count by ones. 63, 64, 65, 66, 67, 68, 69, 70. And how many ones? 1, 2, 3, 4, 5, 6, 7. So 43 plus 10, 27 equals 70. 70 take away 10, 27 equals 43. Okay, now we're going to go on to number 3. So what will the 15th number be in this pattern? So you can work this out any number of ways, but if you notice they're counting by 5s. So 5 is your first. If you're counting by 5s, you could also just think, what is 5 times 15? And that will give you the answer, because you're looking for the 15th number in a number sequence that's counting by 5s. So 5 times 15, now I know you might go, oh, we don't know up to 15, but you do. So 5 times 10 is 50. 5 times 5 is 25. Put those together and you get 75. 75. So the 15th number in a number pattern where you're counting by 5s is going to be 75. Sorry, this is all over the place. I'm getting used to filming myself writing, but it'll be 75. Now, write the first 3 numbers in this pattern for this pattern rule. So it says to start at 7 and multiply by 2. So 7 times 2 equals 14. Now we have to multiply, that's our first number. So we're gonna have 3 numbers. I'm gonna put them here. That's my first number is 7 times 2. Then I take my next number, 14 times 2 equals, now think about it. We know 12 times 2 is 24. So 14 times 2 is just 2 more groups of 2. So let's count by 2s. 24, 26, 28. So my second number is going to be 28. Now it's going to ask you for your third number. So I take my number, 28. I multiply it by 2 times 2. Now you guys can do this by breaking it up, or you can just double it in your head. I'm going to break it up because sometimes doubling it in our heads is not for everybody. So I know 20 times 2 is 40. I know 8 times 2 is 16. So I know that together they are going to be 56. So now I've figured out all 3 numbers in my pattern. Okay, next, we're going to move on to the problem of the day. Oh, no, sorry, missed a last one. What is the rule for the following pattern? So let's look. 11, 22, 11, 22, 11, 22. Well, they're just repeating. It's repeating 11 and 22. That's all it is, just a repeating pattern. So Lisa read 20 minutes for her class assignment. Kylie, we're on the problem of the day, by the way, so just move down to problem of the day. So Lisa read 20 minutes for her class assignment. Kylie read twice as long as Lisa, and Mark read triple the minutes that Lisa read. So how many minutes did they read altogether? Now, this is a multi-step question. We have to think of a couple things before we can solve it. So let's first start with what we know. We know Lisa read 20 minutes. What other things do we need to know to figure out the total? We need to know how much Lisa read, which is 20 minutes. We need to know how long Kylie read, which we will figure out using the information. And we need to know how long Mark read. So break the question down. What are the things you need to know? You need to know these 3 things. We already know Lisa. Let's move on to Kylie. Kylie read twice as long as Lisa. So twice as long means double. So double 20 is 40. Now Mark read triple the minutes Lisa read. Now triple means times by 3. So 20 times 3 is the same as 2 times 3 with a 0 on it because it's by tens. So now we have the total of what everyone read. So they read lots. They read all of these minutes, and all we have to do to figure out how much they read altogether, the total, which is what the question is asking, we have to go 20 plus 40 plus 60. Now, you can do this in your head. If you know 20 and 40 is 60, then all you have to do is 60. So 20 and 40 was 60, right? 60 plus 60 is the same as 6 plus 6, right? Which is 12. Add a 0, it's 120. Now, if you could do all that in your head, great. If you had to write it out like I did, that's also great. Work through the steps, figure out what the question is asking. So right now we have our answer. We know that altogether they read 120 minutes, and you can abbreviate that, but make sure you add the minutes because otherwise it could be 120 seconds. Remember, when we're doing units of measurement, we always put what we're measuring in so that it makes sense to anyone reading it. Now I'm gonna move on to our favorite, long division. So I know that this is something that you guys are getting really good at as you practice, but if you're still thinking, I need that little bit of help, Mrs. Oakes, then you're in luck because I'm going to work through each problem with you. So I'm going to work through each problem and then we will have done it together. And if you've already done these and you just want to check your work, then follow along and check your work, okay? So we start with this one, 6. Well, 6 doesn't go into 3. It goes into 3 0 times. So 6 times 0 is 0. We have a 3. We bring down the 7, 37. How many times does 6 go in? Sorry, I'm a little jiggly here. How many times does 6 go into 37? Okay, I know that 6 times 6 is 36, so it goes into it
6 times. 6 times 6 is 36. Now, I'm going to minus to find the difference, right? I'm subtracting to find the difference. I know I have a difference of 1. Now, does 6 go into 1? It does not. So I'm going to bring down this 8. How many times does 6 go into 18? So you have to think 6 times 3 is 18. So it goes into 18 3 times. Now to make sure that we've checked it, we go 6 times 3 is 18. And remember, in long division, you want to work until you have nothing left to work with. So now you've got the 0. You know that 378 divided by 6 is 0. Let's move on to number 2. So 8. Okay, 8. Does 8 go into 6? It doesn't, because 8 is bigger than 6. So it goes into 6 0 times. 8 times 0 is 0. The difference of 6. Now, I bring down my 8. How many times does 6 go into 8, not 6. How many times does 8 go into 68? Now, I know that there's no product of 8 that's exactly 68, but I do know the closest one is 8 times 8 is 64. So I'm going to say 8, right? 8 times 8 is 64. I'm going to find the difference by subtracting, okay? 8 times, not times, I'm using too many math words here. 8 take away 4 is 4. 6 take away 6 is 0. Now, can 8 go into 4? Nope. 4 is smaller than 8. I can't get any groups of 8 into 4. So I can bring down this 8, okay? So now I'm working with 48. How many times does 8 go into 48? Now I know that 8 times 6 is 48. So it goes into 48 6 times. 8 times 6 is 48. Checking my number, there's no difference. Okay, so all you're doing is figuring out how many times your number can fit into this number. So what we figured out is 8 can fit into 688 86 times. I'm going to move on to the next one. Now, 3 can't really go into 2 because 3 is bigger than 2, so it's going to be 0. 3 times 0, 0, 2. Now, guys, I'm modeling these steps for you because it's going to make it, for those of you who are still practicing the steps of long division, it's going to make it easier for you if you go through the steps. If you want to jump ahead, some of you are jumping ahead, that's okay too, but be patient with me and follow along if that's where you're at. So 3 times 0 is 0. 2, take away 0 is 2. I'm going to pull down this 7. Now I'm working with 27. I know my 3 times tables, and I know that 3 times 9 is 27. So I'm going to put a 9 here. 3 times 9 is 27. I'm going to subtract to find the difference. Okay, and now I have nothing. So then I go to my next number. This is great. I'm right where I need to be. 3 goes into 3 one time. 3 times 3. You could have brought this down if you'd like, I guess. 3 times 3 times 1 is 3. Subtract to find the difference is 0. All right, bear with me while I get good at making videos. Okay, so my next one, number 4. We're on number 4. So 637 divided by 7. So I have to figure out how to do that. So first I say, how many times does 7 go into 6? Well, it doesn't, because 6 is smaller than 7. I can't fit any groups. 0 groups of 7 can fit into 6. So 7 times 0 is 0. I have a 6. I'm going to bring down this 3. Okay, how many times does 7 go into 63? Now, I do know that 7 times 8 is 63. Now, if you want to use a multiplication chart to help you with this, you can do that. If you have a hard time keeping those factors and products in your head, let me know. I can send you a multiplication chart if you don't have one. But I know that 7 goes into 63. sorry, 9 times, not 8 times, 9 times. It goes in there 9 times. 7 times 9 is 63, a difference of 0. 7 go, and then so I have 0. I could bring down the 7 if you want to keep practicing the algorithm. 7 times, how many times does 7 go into 7? It goes in 1 times. 7 times 1 is 7. And then a difference of 0. Okay, so we figured out that you can fit 91 groups of 7 into the number 637. Okay, next one. Sorry for the shaky camera. We're moving on to number 5. So looking here, 4 can't go into 3 because, yes, you're right. 3 is smaller than 4, so it's going to be 0 times. 4 times 0 is 0. So I still have the 3 to work with. I'm going to bring down that 5. How many times does 4 go into 35? So you think about your 4s, count by 4s. Okay, I know it's not 36 because counting by 4s, I've got 4, 8, 12, 16, 20, 24, 28, 32, 36. So it's not, I can't quite get 34, but I do know that I have 32. So 4 times 8 is 32. So it goes into it 8 times. 4 times 8 is 32. Now I need to find the difference. So 5 take away 2 is 3. 3 take away 3 is 0. I have 3 left. 4 doesn't fit into 3. So I'm going to bring down this 2 so I have more to work with. Okay. Now, looking at 32, how many times does 4 go into 32? Well, I just spent some time talking about how 4 times 8 is 32. So I know that one. Looking at the difference, so 4 times 8 is 32, so I'm going to write the 32 down there, check the difference, and find out I only have 0 left, which means I've solved it correctly. I know that 352 divided by 4 is 88. Okay, now we're going to move on to multiplication. This is a marathon, grade 5. You've got lots to practice today. Okay, so we're going to move on to multiplication. So we're going to solve, sorry, it's going all blurry on me here. Let me just refocus my camera. It says solve using your strategy of choice. You can use box, window, partial products, grandma, grandpa, or a personal strategy. So I've decided I'm going to model different strategies every day. Today, I am going to model box window. And to do that, I am going to need my handy dandy whiteboard that I borrowed from Miss LeBay's room. So this is, I'm going to have my whiteboard set up. We're going to start with 44 times 23. We're going to use the box window method to solve this. Again, I'm going to reiterate something I said in some of my other grade videos. If you use a different strategy, but you get the same result, then your strategy is correct, right? If you're using a different strategy and you're getting a different number, you need to go and check your strategy because something's gone wrong in one of the steps. So we're going to start with 44 times 23. So I'm going to write 44 times 23. And I'm going to use box window, so if you remember that from class, it's where we set up, we draw a box. And a window. Okay, and I set up my numbers. Doesn't really matter which way you do it. 40 and 4, 20 and 3. Okay? Now, remember we keep track of our zeros and make sure this works. So we're going to start up here. 20 times 40, 2 times 4 is 8. Now, because I have those two groups of 10, they're both 10s, I'm going to add 2 zeros because I'm timesing by 10. Now, 3 times 4. 3 times 4 is 12. But remember, I'm actually doing 3 times 40, so I can add that 0, right? Remember, if it's a multiple of 10, you have to keep track of your zeros. Now, 20 times 4. 2 times 4 is 8. Add a 0. 3 times 4. I already did that one. I know it's 12. All right. Let's see.
now I have all my numbers. You know that the next step in our box window is to add them. So 800, 80, 120, 12. Gonna add my ones, 2. Gonna add my tens, 10, 11. No, yeah, 10, 11, 11. Gonna add my hundreds, 9, 10. So my answer is 1,012. 44 times 23, 1,012. So, all right, we're gonna go to the next one. 97 times 35. So let's work through that together. Just let me erase my board. Okay, so 97 times 35. I'm gonna write it on my board. 97 times 35. So today I'm modeling the box window method. So I'm gonna make my box, gonna make the window. Make sure that if you're using a different strategy, 90 and 7, you just check that you have it correct. We can use whatever strategy works for us. So we can start with I'm gonna start by multiplying them together. 90 times 30. So I think, okay, I know that 9 times 3 is 27. These two are both multiples of 10. So I'm just gonna add zeros. 2 zeros. Now 90 times 5. Well, I know 9 times 5 is 45. And since it's 90 times 5, I add a 0. Now 30 times 7. Okay, again, I know 3 times 7 is going to be my 21. It's one of my favorite facts. And then I just add a 0 because it's 30 times 7. 5 times 7, now there's no 10, so it's just 5 times 7. 5 times 7 is 35. Now I've done all my multiplying. My next step is to add it all together to make sure it makes sense. So 2,700. Okay, and then I have 210. Remember, we're making sure they all line up. I've got 450, and I've got 35. Okay, I'm gonna add them all. 5, and then 1 and 5 is 6, 7, 8, 9, 7 and 2, 9, 10, 11, 12, 13. I've got nothing else to add. Okay, so 9, 13. I'm gonna use Grandpa's way. 13, carry that 1,000. These are thousands. And then 1 plus 2 is 3. So my answer for 97 times 35 is 3,395. So I'll write that down. 3,395. Okay. Again, whatever your strategy was, it's fine. We will just check that you have the correct answer, because if you don't have the correct answer, something has gone wrong with your strategy. You can always go back and try it again using the box window method. Okay, I'm gonna erase my board. And I'm gonna try again with my last one for today. So the last multiplication that we're gonna do today is 73 times 51. So 73 times 51. I'm gonna make my box and my window. And we're gonna go 70 and 3, 50 and 1. Okay, now going through this, 70 and 3, 50 and 1. Remember, I'm just gonna do multiply, 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 and then add. So 50 times 70 is the same as 5 times 7. 5 times 7 is 35. And because we look at our zeros, our factors of 10, or our products of 10, we add 2 zeros. So that's 3,500. Now, I'm looking here, 70 times 1, well, that's just 70. 50 times 3, I look at 5 times 3 is 15, and I add a 0. Okay? Because there's only one product of 10 there. And then 1 times 3 is 3.
I'm going to add them all up. Remember, stack them, keep them in order. 150, 70, and 3. 0, 0, 0, 0, 3, 5, and 7. Okay, I know 5 plus 7 is 12. So I put my 2 there. Carry my 100 up there, right? 1 and 5 is 6, 7. 3, we have no more thousands to add. So my product, my answer for 73 times 51 is 3,723. So I'm going to go and write that. 3,723. All right, we're done our multiplication. We're going to move on to the next page. Just having issues with it focusing, going back and forth. So I'm going to focus on my next page, which I have right here. Now, this is review of fractions. And fractions are something you do every year. We're going to start reviewing them right now. So we're going to read, it says halves, thirds, and fourths. Halves mean that a whole is divided into 2 equal parts. Each part represents 1/2. Thirds means that a whole is divided into 3 equal parts. Each part represents 1/3. Fourths mean that a whole is divided into 4 equal parts. Each part represents 1/4. That's all it is. It's just dividing into parts. So the first thing it asks us to do is to match each fraction to the correct picture. So 1/2. Well, we learned up there that halves are 2 pieces. So this one has 2 pieces. Sure. This one works. 1/4. So I'm looking for one that has one out of 4. Oh, this one works. So I would match it. 1/3. So there's going to be 3 equal pieces with 1 shaded in. And I see that right here. Okay, 2/4. So this kind of looks like a half, but if you look closely, my photocopy isn't that great, but if you look closely, it's actually divided into 4 pieces. So 2/4. 2/3. Oh, 1, 2, 3, and 2 are shaded. That's 2/3. And 3/4. So looking here, my last one that will match is here. Oh, what a beautiful picture. All right, now it's asking to draw a picture that represents 3/4. So I'm going to go with our circle. And fourths, another word for fourths is quarters. Quarters, quarters. You might have heard that when you're talking about money. And if you think about it, 4 quarters makes $1. So I've made mine, and it says represents 3/4. So I would have to shade in 1, 2, 3. 3/4. My next one, draw a picture that represents 1/2. Circle. Remember, half is a group of 2, so I'm gonna do 2 equal parts. Make sure they're equal because otherwise they're not really a fraction. And then I'm gonna color in one of those halves. Okay, draw a picture that represents 2/3 and make my circle. I'm gonna divide it into 3. When you're dividing a circle into 3, it kind of looks like a peace sign or the beginnings of a peace sign. So draw a picture that represents 2/3. I have my 3 pieces, and I'm going to color in 1, 2. Read carefully, 2/3. 2 out of 3 are colored. Same thing with this. 1 out of 2 is colored. So it says, does this picture represent thirds? Why or why not? Well, look at your shape. Is it divided into 3? Yes. Are these 3 pieces equal? Yes. So you can say yes. There are 3 equal parts of a whole. So this would be our whole, right? It's like you had a whole chocolate bar and you broke it into 3 pieces of a whole. Now make sure it's the one with the W. Otherwise, H-O-L-E means like a hole that you dig in the ground. W-H-O-L means the whole thing, like the whole pie or the whole pizza. Fractions always makes me hungry. All right, it says, does this picture represent thirds? Why or why not? Now, yes, it's broken into 3 parts, but are these parts equal? I hope you said no. They're all different shapes and different sizes. So, no. these are not equal parts. Fractions are only equal parts. These are not equal parts. And if you ever want to know if something's equal, I always used to think, okay, if you guys were sitting in front of me and I had a piece of chocolate that's this piece of chocolate, and I say, I'm going to share this equally, and I gave you this tiny piece, but your friend this huge piece, would you feel that was equal? No. But if I look over here, these two are definitely equal, or these three are definitely equal. That would be fair. So fractions, you're trying to make them all the pieces equal. Okay, whatever you're dividing it into, I'm dividing this into 3. These are 3 equal. They're all the same size. I'm dividing this into 3, but I didn't do it equally, so they're not actually a fraction. They're just a triangle that's broken up into 3 pieces. All right, draw a picture of what fifths might look like. So fifths, what do you think? A group of, if fourths is 4, fifths is probably going to be 5. So beep-a-doop-a-doo. I'm going to draw a chocolate bar. And if I want to divide it into 5 equal pieces, I need to draw 4 lines. So I'm going to 1, 2, 3, 4. I'm doing my best to make it equal, but I mean, it doesn't have to be perfect. It says might look like. So 1, 2, 3, 4. And I'm going to count 1, 2, 3, 4, 5 pieces. Okay, now it's asking you to draw a picture of what eighths might look like. So I'm going to do the same thing. Drawing a chocolate bar because I'm really hungry for chocolate. And I'm just going to think, okay, again, my chocolate bar is not perfect, but that's okay. Draw a picture of what eighths might look like. You always want to draw, if I'm going to make eighths, I need to draw 7 lines. So I'm going to go, how do I space these out? 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7 lines. And let's count, make sure we have 8 pieces. They're equal-ish. 1, 2, 3, 4, 5, 6, 7, 8. Now they're equal-ish. We'll say they're equal enough for right now. So I hope that you enjoyed this really long math lesson. I just looked at my timer and it was 31 minutes of math for you today. Thank you for sticking with me through it. I hope that your math makes sense to you. If it doesn't, please, I'm going to turn this around. So once you're done your math, make sure that you know you can send me a question if you have a question. If you want to send me a message and just said, I did my math, Mrs. Oakes. I really like the long division, or long division is something I need to keep practicing. Whatever works for you, make sure you let me know how it went. Send me a dojo message. Send me an email if you want. Dojo's better. And tune in tomorrow for more math.